Welcome back to my YouTube channel. Today we are going to see about what is canned foods. Canned food means food that has been preserved inside an airtight container, usually a metal can or glass jar, to increase its shelf life. For example, canned fruits, vegetables, fish and meats, soups and beans. Canning is a method of preserving food by sealing it in airtight containers like tins or glass jars and heating it to kill germs so that the food stays safe and fresh for a long time. For history of canning, canning started in the early 80s. It was first developed by Nicolas Appert, a French inventor. He found that food stays fresh longer when sealed tightly and heated. Later, tin cans were introduced, making canning faster and more useful. Today, canning is a worldwide technology used to store food safety for months or even several years. Importance of food preservation. It prevents spoilage, shelf life, nutritional value, food waste, and food availability. Prevents spoilage. Canning stops the growth of microorganisms like bacteria, yeast, molds that cause food to spoil. Extends their shelf life. Food can be safely stored for months or even years without losing its quality. Maintains nutritional value. Proper canning retains most vitamins, minerals, and natural nutrients. Reduces food waste. Surplus seasonal produces can be preserved and used later, reducing their wastage. Ensures food availability. Provides a steady supply of food during off seasons, emergencies, or when fresh food is not available. Principle of food canning. The principle of food canning are based on destroying harmful microorganisms and preventing their re-entry. During canning, food is heated to a specific temperature to kill bacteria, yeast, mold, and enzyme responsible for spoilage. After eating, the food is sealed in airtight containers, which prevents contamination and stop microbes from entering again. As the sealed containers cool, a vacuum is formed, helping maintain freshness and prevent oxidation. Proper sterilization and pasteurization ensures the food remains safe for long-term storage, while suitable containers help preserve the color, flavor, texture, and nutritional quality of the food. Types of canned foods. There are several types of canned foods. Canned fruits, for example, mango, pineapple, peach, and cherries. Canned vegetables, for example, peas, corns, beans, and carrots. Canned meat and poultry, chicken, beef, and sausages. Canned seafoods, for example, tuna, sardines, salmon, and mackerel. Canned soups and broths, ready to eat or condensed soups. Ready to eat meals, pasta dishes, curries, mixed meals. Canned legumes and pulses, for example, kidney beans, chickpeas, and lentils. Canned juices and beverages, fruit juices or drinks. Canned sauces and purees, tomato sauce, puree, and gravies. Fruits and vegetables, preserved to extend shelf life and prevent spoilage. Cleaned, peeled, and cut before packing into a can or jar. Heat processed to destroy microorganisms and enzymes. Fruits are canned in sugar syrup to maintain sweetness, color, and texture. Vegetables are canned in brine or water to retain flavor and firmness. Keep seasonal produce available year round. Maintains most nutrition, making them a healthy option. Reduces food waste by preserving surplus harvest. Meat and fish products. Processed to ensure long term preservation and prevent microbial spoilage of meat and fish. Cleaned, cut, and cooked or pre cooked before being packed into cans. Sterilized at high temperature to destroy harmful bacteria like Clostridium botulinum. Canned in brine, oil, broth, or sauce to enhance flavor and shelf life stability. Common canned meats include chicken, beef, pork, sausage, and luncheon meat. Common canned fish include tuna, sardines, salmon, mackerel. Vacuum sealing prevents recontamination and keeps produces safe for consumption. Retain protein content and provides a convenient ready to eat food option. Useful during emergencies or lack of refrigeration due to long shelf life. Ready to eat meals. Fully cooked and processed meals are sealed and sterilized to make them safe for long term storage. Require no further cooking, only heating or can be consumed directly from the can. Common RTE canned meals include curries, pasta dishes, soups, stews, biryani, and mixed vegetable dishes. High temperature processing destroy microorganisms and ensure food safety. Packed in airtight containers to prevent contamination and maintain freshness. Convenient for travel, emergencies, and quick meals as they save time and effort. Long shelf life allows storage without refrigeration. Balanced nutrition preserved, although slight texture changes may occur during heating. Now we will see canning technology and equipment. Preparation of equipment. Washing machines, peeling and cutting machines, blanchers are using washing machine used to clean fruits, vegetables, meat or fish before processing. Peeling and cutting machines. Peeling and cutting machines are mostly used to remove skins and cut fruit into uniform sizes for even processing. Blanchers quickly heat vegetables to inactive enzymes and preserve color and texture. Filling machine. Manual or automatic fillers are used to place food into cans or jars to accurate quantity. Ensures uniform filling with help maintain product quality and prevents underfilling or overfilling. Liquid fillers and brain syrup or sauces to maintain flavor and improve heat transfer. Sealing machines, known as can seamers. These machines seal metal cans tightly to prevent contamination from microorganisms. For glass jars, lid capping machines create airtight closures. Proper sealing ensures no air enters, preventing microbial growth. Heat processing equipment, retards and autoclaves are used. Large pressure vessels where filled cans are heated at high temperatures to destroy microorganisms like Clostridium botulinum. Batch retards and continuous retards are used. For batch retards, process small to medium quantities at a time. Continuous retards used in large industries for constant production. Steam or water based heating system. Heat can uniformly ensure sterilization. Cooling system. After eating, cans are cooled using water sprays or cooling tunnels. Rapid cooling prevents overcooking, protect texture and help form a vacuum seal inside the can. Labeling and coding machine. After cooling, cans pass through machines that apply labels, brand information and batch codes. Coding is essential for tracking protection during quantity control. Storage and packaging equipments. Finished cans are stored in temperature controlled warehouses. Palletizing machines stacks cans safely for transport. Carton packing machines pack multiple cans into boxes for distribution. Quality control equipment. Can testers check the leaks, dents, or improper sealing? Microbiological testing system monitor food safety. X-ray and metal detectors ensure no foreign objects are present inside the can or outside the can. Pressure and vacuum testers verify proper sealing of cans. Automation and monitoring technology. Sensor and computer controlled system for temperature, pressure, and time regulation. SCADA system for monitoring real time operation. Robotics for automated handling, packing, and sorting. Cleaning and sanitation system. Equipments like CIP systems ensure machinery is sanitized without dismantling, prevents contamination, and maintains hygiene standards. Microbiology of canned foods. Canning destroys microorganisms and spores through high heat to achieve commercial sterility. Maintain spoil Main spoilage organisms include Clostridium botulinum, Clostridium sporogenes, Bacillus, yeast, and molds. Low acid foods need higher heat 121 degrees Celsius because they support spore growth. Spoilage types include swelling, flat source spoilage, and thermophilic spoilage. Proper heat processing and airtight sealing prevent microbial contamination and ensure long shelf life. Microbial spoilage of canned foods. Swelling of cans occurs due to gas producing bacteria like Clostridium botulinum and Clostridium sporogenes. Flat source spoilage results from heat resistant Bacillus species that cause soaring without gas. Thermophilic spoilage is caused by heat loving bacteria that survive inadequate heating. Spoilage lead to acidification, bad odor, discoloration, gas formation, and off flavors. Microbial growth. Microbial growth occurs only when heat processing is inadequate or the container seal is fault. Spore forming bacteria like Clostridium bacillus may survive insufficient sterilization and germinate inside the can. Growth mainly happens under anaerobic conditions as oxygen is absent in sealed cans. Factors supporting growth: high moisture, nutrients, pH 4.6, and improper storage temperatures. Microbial spoilage. Swelling of gas production caused by Clostridium botulinum and Clostridium sporogens which produce gas inside the cans. Flat spore flat source spoilage caused by heat resistant bacillus and bacillus coagulans, no gas is produced, only soaring. Thermophilic spoilage. Heat loving bacteria survive processing and grow during storage at high temperatures. Microbial spoilage signs: sour taste, bad odor, color change, cloudy liquid, gas formation, and bulging cans. Spoilage occurs when processing temperature, time, sealing, or storage conditions fail. Clostridium botulinum. Clostridium botulinum is an anaerobic spore forming bacterium that can survive improper heat processing. It grows in oxygen free canned foods, especially low acid foods, pH 4.6. Produces a deadly botulinum toxin causing serious food poisoning. Causes gas production leading to swollen or bulging cans. Prevented by pressure canning at 121 degrees Celsius, proper sealing, acidification of low acid foods. Thermal death time. Thermal death time is the minimum time required to kill a specific microorganisms or its spores at a given temperature. Used in canning to ensure the destruction of heat resistant bacteria, especially Clostridium botulinum. Higher temperatures require less time, while lower temperatures require more time to achieve sterilization. Thermal death time helps determine the processing schedule, time plus temperature for a safe canning. Ensure commercial sterility, preventing microbial growth, spoilage, and foodborne illness in canned foods. Tin plated steel cans. Most commonly used, strong, airtight, corrosion resistant, have inner lacquer coating to prevent reaction with food. Aluminum cans, lightweight, rust free, good heat transfer, used for beverages, soft foods, and ready to eat items. Glass jars and bottles are used, chemically inert, transparent, and reusable, suitable for fruits, pickles, sauces, and baby foods. Require metal lids for airtight sealing. Retortable pouches, flexible, heat resistant, multi layer pouches, used for ready to eat meals, curries, fish, and meat. Faster heat penetration than metal cans. Plastic containers, used in some modern canning, lightweight and resistant to breakage. Quality control and safety standards. Raw material inspection, washing and sorting, process control, can integrity check, chemical quality test, microbiological testing, sensory evaluation. Nutritional aspects: retention of most nutrients. Canning preserve carbohydrates, protein, fat, and minerals effectively. Nutrients like calcium, iron, and fiber remain largely unchanged. Vitamin stability: fat soluble vitamins like A, D, E, K remain stable during canning. Some loss of vitamin C and B vitamins occur due to heat processing. High shelf life of vitamins. Nutrients are protected from oxygen, light, and microbial spoilage, helping maintain quality for long periods. Fortification in some products. Certain canned foods like juices, milk, baby foods may be fortified with vitamins and minerals. No need for preservatives. Canning itself acts as a preservation, so no chemical preservatives are needed, maintaining natural nutrient profiles. Convenience and safety. Ready to eat and safe for consumption, providing balanced nutrition quickly, especially in emergency or storage situation. Possible increase in antioxidants. Heat processing can increase bioavailability of some antioxidants. For example, lycopene in canned tomatoes. Sodium and sugar concerns. Some canned foods may contain added salt or sugar affecting nutritional value. Low sodium and no sugar options are available. Shelf life and storage. Long shelf life. Most canned foods have shelf life of 1 to 5 years when unopened. Commercial sterility, heat processing destroy microorganisms allowing long-term stability. Low acid foods like vegetables, meat and fish shelf life 3 to 5 years because they are processed at high temperature. High acid foods shelf life of 1 to 1.5 years due to natural acidity affecting can corrosion. Nutrient stability over time. Shelf life affects vitamins like C and B, but proteins, carbohydrates, and minerals remain stable. Storage. Cool and dry environment. Avoid direct sunlight. Do not store in a damp areas. Keep away from freezing. Check cans regularly. Avoid opening of cans. Advantages and limitation. Advantages of canned foods: long shelf life, nutrition, preservation, safety, seasonal availability, reduced food waste, no need for chemical preservatives, and cost effective. Limitation of canned foods: nutrient loss, high sodium or sugar content, metal leaching risk, altered taste and texture, risk of spoilage if mishandled, limited variety for some foods, and environmental impact. Economic and industrial importance. Economic importance of canned foods. Value addition to agricultural produce. Reduction to post harvest losses. Employment generation. Boost food processing industry. Income stability for farmers and fishermen. Export potential. Cost effective for consumers. Support for other industries. Recent advances and research trends. Tells you if food is fresh, shows temperature changes, detect bad gases inside the can, release protective substances, nanotechnology in packaging, smart quality checking in factories. Thank you.